Dr. Albert, meanwhile, you can check your slides.
Okay, sir.
You can check your slides by sharing it. We will wait just. Okay. Okay, it is visible now. Okay. You can unshare it. We'll start within 2 minutes.
So, sir, shall I start the introduction, please?
Yes, madam. Just wait. I think. Okay, so I welcome Dr. Alexander, who will be giving the lecture on role of machine learning in power electronics from this is actually PLS lecture series. It is organized under both PLS and IS chapters and in Industrial Relation Committee of IEEE Madhya Pradesh section. Before I go to Dr. Namke Yadav for introducing the speaker, I request all the participants to mute themselves. And if they have any queries or anything about this session, they should write in the chat box. Okay, I now hand over to Dr. Namika Yadav, who will be presenting the introduction of the speaker, Dr. Alexander. Thank you.
Thank you, Dr. Akhilesh. Before starting the speaker introduction, I would like to thank Dr. Albert for agreeing to deliver this lecture for the benefit of the PhD scholars, AMTech students, and various faculty members. Thank you, sir. Dr. S. Albert Alexander is the recipient of prestigious Raman Fellowship, Raman Research Fellowship from the University of Grant Commission, Government of India. He is a postdoctoral research fellow from Northeastern University, Boston, Massachusetts, USA. His current research focuses on fault diagnostic systems for solar conversion systems and smart grids. He has 15 years of academic and research experience. He has published 57 technical papers in international and national journals, including IEEE Transaction, IET, Elsevier, Taylor and Francis, Springer, Wiley, etc., and also presented 53 papers in national and international conferences. He has completed 4 Government of India funded projects and 4 research projects are ongoing with the overall grant of amount 2.3 crores. His PhD work on power quality earned him a national award from ISTE, and he has received 25 awards from his meritorious academic and research careers, such as Young Engineer Award from Institution of Engineers India, Young Scientist Award from SPRERI, Gujarat, Best Researcher Award from IEEE Madras section, etc. He has also received the National Teaching Innovator Award from MHRD. He is an approved Margdarshak from AICT Government of India. He is the approved mentor for change under Atal Innovation Mission. He is an AICT approved translator under the National Education Policy to translate the regional languages. He has guided 32 graduate and postgraduate projects. He is presently guiding 6 research scholars and completed 5 their PhD guidance. And he is a member and in prestigious position in various national and international forums, such as senior member of IEEE, Vice President for Energy Conservation Society of India. He has been an invited speaker in 250 programs covering 9 Indian states and also at USA. He has organized 13 events, including faculty development program, workshops, and seminars. He completed his graduate programs in electrical and electronics engineering from Bhartiya University and his postgraduate program from Anna University, India. Formerly, he worked as a professor in the Department of Electrical and Electronics Engineering, Kongu Engineering College. Presently, he is working as an associate professor in the School of Electrical Engineering, Vellore Institute of Technology, Vellore, and also doing research work in artificial intelligent controllers, smart healthcare systems, smart grids, solar PV, and power quality improvement techniques. He has authored the following books in his area of interest. First one, The Basic Electrical Engineering by Khanna Publisher under AICTE Government of India. Second, The Design and Simulation of Electrical Machines with MATLAB under Nova Publisher. Third, Power Electronics Converter for Electric Vehicles under CRC Press. Fourth, Power Electronics Converter for Solar PV System under Elsevier. Advanced Deep Learning for Engineers and Scientists from Springer, and computational paradigm techniques for enhancing electric power quality under CRC Press, basic electrical electronics and measurement engineering, Anuradha Publisher, and final eighth one, special electric machines from Anuradha Publisher. So these are very small things that we have mentioned under the biography of Dr. Albert Alexander. There are many more, but to have a concise, we have included few one. So we are having a very renowned researcher in the field of power electronics among us, Dr. S. Albert. So I hand over the mic to you for further presentation, sir.
Thank you so much, madam. Am I audible?
Yes, sir.
Thank you so much, ma'am. Thank you. So I sincerely thank Dr. Anamika Yadav, ma'am, for giving me this opportunity to deliver the lecture on role of machine learning in power electronics. I wish to thank all the members and coordinators and participants from IEEE PELS Madhya Pradesh section and IES IEEE Madhya Pradesh section and IRC IEEE Madhya Pradesh section, and all the students and all the participants and faculty friends from NIT Raipur and all the students who have been assembled over here to hear the lecture on role of machine learning in power electronics. I once again thank Dr. Anamika Yadav ma'am for giving me this opportunity, and let us move on to our session. So here for the next 1 hour, I'm going to explain you about how this machine learning is helpful in meeting the performance improvement in power electronics. You can ask a question, sir, already we know that there is a neural networks is available and fuzzy logic controllers are available and genetic algorithms and particle swarm optimization and simulated annealing, etc., everything are being available and many papers are published under this area. Why we are going to focus on machine learning? Because whether AI and machine learning and also deep learning and also this ANN techniques are all different, are all same? That is a question posed by all the researchers. Because many research, whenever we want to complete, we want to implement in any one of these. Okay, even you can go with a conventional PI controller or a PID controller or a conventional mathematical modeling of a system, that is also acceptable. Okay, if you are improving the performance. In addition to that, we are also going to focus on some kind of intelligent methods for improving the performance, not only in power electronics, but also in healthcare systems, agriculture, and also in various domains we are using this machine learning. But now in few years, okay, so in a few years, we can able to see many people are focusing their attention towards learning the concept called machine learning. And even during the admissions of BE, BTech, many people are looking on to study computer science engineering, especially getting the domain in machine learning and keeping all our core domains like mechanical and electrical and civil in frame. So, but the thing is that, you should understand this mechanical, electrical, civil. So they are all the front runners in the engineering, whereas this machine learning, you should understand it is just a tool. Okay. So the subject, we can able to include a computer science engineering also here as a subject, whereas these topics are a tool in solving a problem. So we can able to work with any power quality improvement or fault diagnostic systems or else MPPT power converter, or else any kind of thing in a power electronics, this machine learning will be helping as a tool as like our PI, PID and mathematical modeling based controller, provided this mimics the human brain as like neural network, fuzzy logic, etc. So you can able to understand all these topics like artificial intelligence, machine learning, deep learning, neural networks, fuzzy logic, and optimization methods. Everything comes under the same umbrella. But the direction in which they are rooting out may be different. The direction in which they are going is different. But the meanwhile, everything comes under the same umbrella. So when we talk about on artificial intelligence, so it is just mimics the human brain. For an example, you are giving a set of X1 and what is the related X2, that is called as the artificial intelligence. You are going to set of training of X1 and X2 and you're going to make a system to learn and adapt like that. So here we come across a new word called learning. Learning is normally defined as tuning. That's called learning. So even we are going to make a PI controller tuning. That is, you have to tune the value of KP value, KD value, and KI value. There are so many techniques available, such as Ziegler-Nicholas method and velocity method and acceleration method. Those methods are helpful to improve the KP, KD, KI value, to obtain this value. So to get the value, we are going to tune this parameters. Here also, we are going to tune the parameters. So learning means it is also called as tuning. Up to what range you have to tune means until you get your desired output, you should not stop tuning. So now you understood that what is meant by learning and what is meant by intelligent systems. So now in this presentation, we are going to see, initially we are going to discuss about machine learning, and with the help of few case studies, I am going to explain you how this machine learning is helpful in solving the problems in power electronics. So let us say across artificial intelligence as an example, we are going to discuss about the artificial intelligence of our grid connected solar PV system. In which are the areas? Okay, because many peoples will say that, sir, whatever the work which I am taking, that has been dealt by other researcher. So I thought of taking a particular work, but that has been dealt by other researchers. But when we talk about an artificial intelligence, as I already mentioned you, this comes under the umbrella of ANN and a fuzzy logic controller or a machine learning or a deep learning, etc. So these techniques can be useful for grid connected PV systems. For an example, when a solar photovoltaic system, which is consisting of a positive and a negative terminal, when it was interested to connect with the grid, it comes across so many components in between. That is, let us say that this solar PV provides a DC power. I want to convert with the help of an inverter for the DC to AC, and then after converting this DC to AC, I want to make the synchronization before I connect it to the grid. So for that, let us say one by one. So if you want to make this particular system, the control can be either a grid connected system or a standalone system. So for those applications, for a grid connected means I can able to make use of a machine learning, or else I can able to make use of intelligent methods to see whether my system is properly synchronized or not. Okay, so if it is not properly synchronized, it will result in blackout or brownout, which is called as the complete power shutdown of the entire system. Or let us say that for many projects, we are working with a standalone system where the grid will be replaced by normal loading conditions. For each and everything, we need appropriate control. And next one, if you want to make a maintenance of the components available in the solar PV based grid connected system, I want to find what is the remaining useful life of a solar panels, of a battery, of a power converters or a conducting cables. And also I can able to monitor the condition. That is, we call across something like a state of charge or a depth of discharge and lifetime estimation and the survival estimation. So those things comes under the maintenance. And the next one I will talk about on cyber security. That is, whenever the data, for an example, from the solar, I'm collecting the data, from inverter collecting the data, from the grid, I'm collecting the data. So all these things, the data I'm taking as a storage on the cloud. So I need a cloud cyber security, either in the active mode or the passive mode. Active mode means all the things, it will be in a vigilant. Passive mode means the cyber security provides an additional password, but we cannot able to look on to that whether the secure communication has been made. So both the things, it provides a secure communication, providing an active and as well as a passive. And similarly for the forecasting, we can able to make sure that, that is in the demand side management. That is, now many people are working with the energy management, power management, and also while connecting, instead of in the load side, we are connecting the electric vehicle. So based upon that, we are estimating that how much of power is required from the input sources, and whether the power is sufficient for in order to run the electric vehicle or some kind of thing. And also we can forecast the power. So for an example, this artificial intelligence, I will give example case study for each and everything what I'm showing now. It's only a indicative diagram. In the forthcoming slides, I will explain you how this indicative diagram can be used in the machine learning with the help of very simple examples, very simple examples, general examples, and then I will correlate that example with our power electronics. And then when we're going to the design of the power system, the solar PV based grid connection system, we can able to work with the PV sizing as per the requirements, and then the parameter identification. That is, what are the parameters are required for the grid connected system and how we want to identify those parameters. Okay, so with this particular thing, we are going to see there are so many research problems existing or available in this area. That is interconnection of intelligent systems for power electronics. So without power electronics, we cannot be able to imagine the control. Because many a times we say that, we are studying the subject called EEE, electrical and electronics engineering. So most of the universities, when they take about NIT Calicut, there is no electronics engineering. We call only the Department of Electrical Engineering. Okay, we talk about on electrical engineering. Okay, but most of the times as a electrical and electronics engineering, but the real advantage of power electronics is the only subject which combines the features of electrical and also the electronics. That is, power electronics can be defined by using the electronic components for electrical conversion. That is called power electronics. So the only subject which combines the concept of both electronics and electrical, because some subjects like signals and system, digital or analog, those subjects you deal only with the electronics. Or some subjects like electrical machines, AC machines, special electrical machines, we focus only on electrical. But the power electronics is a subject which combines the combination of both electronic and as well as electrical. So that shows the importance of our PELS, Power Electronic Society. And in addition to that, we talk about on EEE for electrical, but this power electronics is helpful in the CCC. What is CCC? See, power electronics can be useful for CCC. First C is for conversion. So converting from AC to DC or DC to AC, DC to DC, AC to AC, for those kind of conversion, we use power electronics. And second C is for control. Okay, so control means, let us say that I want to control a DC motor, I want to control a AC machine. In the electrical vehicle, we talk about on three-phase induction motor in a Tesla or BMW. We are having a three-phase induction motor or a synchronous motor or permanent magnet brushless DC motor. For the control of that, we need power electronics. And what about the next C? The next C is for conditioning. What is meant by conditioning? Conditioning means, for an example, whenever we take bath, okay, so we apply shampoo. In addition to that, applying shampoo, we apply conditioner. What is meant by conditioner? Conditioner is a smoothener, which will smoothen our hair. Okay. Similarly, in any circuit, whenever your waveform is highly distorted like this, with help of power electronics, we can able to smoothen the waveform like this. So that is the realistic practical advantages of power electronics. So now we understood that what is meant by power electronics and what is the various things of the power electronic systems. And now we are going to see what is meant by a machine learning. Machine learning is not at all a very new concept. Okay, when we talk about our machine learning, okay, so it has the ability for learning. Learning means already I say it is a tuning, okay, without being explicitly programmed. That is, you are going to create a model. That's all. When I will execute one practical problem, that is, I want a model. So let us say that the model name is X. You will give the set of inputs like voltage and current. This model will receive the voltage and current. What action to be performed on receiving this voltage and current? Let us say that it has to create some alpha from a switch. So that is called as the machine learning. I want to create a model. So in 1959, Arthur Samuel, he has given the definition for machine learning that it is a field of study which gives the computers to learn. So we does not require an explicit program. That is, we normally what we will write in any programming language, even to add two numericals, we'll give header files, we'll give the data types, we'll give the what is the input, what is the output, and everything like that. We'll give something. But here we no need explicitly to be get programmed. So I will also explain you with help of on a Python program to show you that how simple the implementation of machine learning is. So let us say that, Arthur Samuel, he made a checkers playing program. That is, he created a program. So that program will play 10,000 games against itself. So he has made a model. Okay, so that model, let us say the model is X. So that model has the ability to play the checkers game. Let us get a card game, 10,000 game against itself. So we made a workout with both positions were good and bad. So we made that whenever the game is win, we made that as a good. Whenever the game is lost, we talk about on bad. So the good and bad of the game is decided depending upon winning and losing. So we can able to understand as per the definition given in 1999 by Tom Mitchell, he said that, a computer program is yet to learn. So it was learning by experience E. Normally, even whenever we want to eat the food on our right hand, okay, even if you want to write in your right hand, or even if you want to walk, swim, or you want to play or drive the car, everything you learned or tuned yourself with the help of your experience. So this experience has been made with help of some task. Okay, even for driving a car, you got a very great experience by making this task again and again and again and again. You got an experience. So one day you will achieve this performance P. So we can able to understand that for everything, for any project in power electronics, we want this ETP. ETP means that is experience and then task and then programming. Let us performance measure. Let us say that you want to reduce the harmonics. That is your task. If you want to reduce the harmonics as a task, okay. So what you will do, you have to make something from experience. That is why the harmonics are increasing. What is called triple harmonics and how this harmonics can be suppressed. So based upon the experience, you are getting some solution. And then you're giving some measure to improve this power quality. And finally, you're achieving the performance that as your THD value is less than 5% or less than 2%. So in any machine learning, whatever you take, you require to understand this ETP. For an example, with the same kind of this Arthur Samuel's program, the program is running 10,000 games. Okay. And the task is to play the checking games. And the performance is either you win or lose. Similarly, you take a power electronics problem. So you are having the experience of connecting the circuit and then you are checking with a different loading conditions, different geographical conditions, a different set of conditions. And your task is to improve the power quality. And then performance is you have so many performance parameters. Let's starting from voltage gain, current gain, efficiency, and then less harmonic distortions and everything. So this is the thing. So whenever you want to achieve the performance, obviously you should not underestimate the experience. That is the reason in any department is concerned, in any universities, we want the people to be much more experienced to handle this accreditation, to handle the very big projects. We want some experienced people. Okay, the reason is, that is in order to improve the performance parameters. Okay, it does not mean that all the youngsters will not never improve the performance parameter, but the experienced person, they have undergone so many wins and losses. So if you keep on winning means you will not learn anything new. We want so many losses as well. The experience is a mixture of winning and losing. So based upon that, it has been perfect thing. And then the task is to play the checkers, and then this performance is to win or lose. So there are various types of algorithms are available in machine learning. So the basic task is, one is called supervised algorithm and another one is called unsupervised algorithm. In most of the power electronics based application, we normally make use of supervised algorithm. That is, the target. So whenever you know the target, then it is called supervised algorithm. For an example, for whenever you're solving the problem of MPPT for given set of voltage and given set of current, you need to know what is the value of your duty cycle alpha, or else we call it as a D. So for the given set of voltage of 12 and ampere of 6, and what is the value of duty cycle of 0.6, that is, for given set of inputs, what is the corresponding output. Then it is called supervised. So you have to teach the computer how to do something and then let it use it new found knowledge to do that. What does it mean? That is, you are training your machine learning model such a way that for 12 volt and 6 ampere, and then your duty cycle is equal to 0.6. That is, you are training the model like that. But now you are finding a new data. New data means you are giving some 10 volt and 3 amperes. But you train the system for 12 volt to 6 amps. But now the data is coming as 10 volt to 3 amps. But you have not trained the system for this corresponding data. You have not trained it. But you train the system for 12 volt to 6 amps. But what the machine learning will do, so it is biggest asset is, it is called adaptation. And it is the biggest strength is called, it is intelligent. What is called intelligent, or it is also called as a smart. We normally call the word called smart grid and all. What is meant by smart? Smart means, let us say that I'm going to give you on a small case study for a smart. So I'm taking my son, taking my son to a marriage hall. I'm giving some 3 data sets. That is, in a marriage hall, you should be very silent and you should be with the parents and you should not take other belongings. So I have given some 3 set of data and I'm taking into the marriage hall. And the next day, I'm going to take my son to a temple. So the temple also, I'm giving some inputs for my son. That is, you should be very silent. You should not disturb others. You should not take other belongings. So I've given some inputs. On the next day, I'm going to take my son to my university, but I've not given any data set. Okay, because he just came to accompany me. So because of emergency, I'm not given any inputs, but suddenly my vice chancellor is asking me to meet him. My vice chancellor is asking me to meet him. But this son is also thinking that I'm also want to come along with you. He's not interested to stay alone. He want to come along with me to the vice chancellor's office. So, but I have not given any data set. But if he behaves in the vice chancellor office based upon the earlier data set, means that is called smart and intelligent. So for an example, you no need to give thousands of data, because many people will say that, sir, I have collected the data, 1,000 data, sir. So my work is very perfect. No. Sir, I have collected 50 data, sir. Whether my work is perfect? No. It means that even if you're having a 3 data set, and if you're train it properly, means that is your effective system. So the effectiveness of your system, it does not mean that how many data set you collect, how many data you orient. The real beauty or the real outcome of the data, it always lies that, how many useful data you are having. So in the supervised learning network, I'm saying that for a 12 volt and 6 amps, I'm giving this corresponding duty cycle, but I have not trained for the other set of data. But my machine learning, what it will do for 12 volt and 6 amps, I have given the result like this. So for 10 volt and 3 amps, I have to give the duty cycle ratio of so and so. So it will calculate of its own based upon the earlier knowledge. Based upon the earlier knowledge. That is called supervised. What is called unsupervised? Unsupervised means you are going to make a computer to how to do something. You are going. So supervised means you are teaching. You are teaching. But here the unsupervised, the computer will learn something. You are not teaching it because you are not showing that what output it has to bring. For example, in unsupervised, you will give the voltage and current, but you will not say that what to do with the voltage and current. But what the computer will do, it will learn from voltage and current to do something. And it will use to determine the structures and patterns in data. But normally the unsupervised learning, what we will do, we'll make some clustering, we'll go for some classification like problems, will comes under the clustering, will comes under the unsupervised. But normally the power electronics, we prefer the supervised, whereas we are keeping some set of target. And another set of learning is available that is called reinforcement learning. That is, in addition to the input, whatever you are giving, in addition to that, certain environmental parameters, certain external parameters will force something to learn. That is called reinforcement learning. So everything has its own name meaning. So many people, they will be working at the reinforcement learning. That is, in addition to the data, voltage and current, they will give some other parameters. Okay. For an example, some environmental parameters. So for this particular geographical location, the temperature also will change. So you are going to include this temperature for getting your output. That is called reinforcement learning. And recommender systems means, that is you are recommending some kind of algorithm for some kind of applications. So these are the types of learning. So here in this IEEE PELS webinar, what we are attending today, we are going to make some practical advice that how to apply this learning algorithms and we are going to learn some sort of tools how to apply them. Normally, we are using the MATLAB as one of the tool, and now we are also using some Python coding to apply these tools for solving the power electronic based problems. Now let us say, that we are going to talk on simple thing of supervised learning. So this is one of the very common problem type in machine learning. Supervised is a very common in the machine learning. So starting with an example, I want to predict the housing prices. So this is a general problem to make the students to get understand with the help of machine learning, how to predict the housing prices. With the electrical concept, you just imagine that how to predict electricity prices. Okay, so you are paying some electricity bill in 2023. You want to predict the electricity prices for 2050 or some other years later, or else you're paying the money. So we want to imagine that pricing will be like that. So the important prerequisite for all the machine learning is data set. So if you're having data set in your hand, your work is 99% over in machine learning or in any other systems. In the artificial intelligence, your work is 99% over if you have the data set in your hand. Many a times, when I was working in United States, I used to see the people, they will be working for a 6 months project. Okay, they will be working for 6 months project. So they are having the data, they will spend most of the times in collecting the data. And then they will spend very less time in writing the program, because writing the program is just 1%, altogether 100%. So you can able to complete the work within 2 months. For an example, if your 6 months is your master's project, you should complete your work in 2 months, and the remaining 4 months we have to spend for writing the paper. But normally what is happening, we are making vice versa. 4 months we are spending for collecting the data, spending for literature review, and then writing some courseworks and all. And we spend only the 2 months for writing the paper. So that cannot be able to result in a very good publications like IEEE Transactions or Springer or Elsevier. So always we have to focus that we have to complete the work within 2 months. You can ask a question, sir, how to complete the work within 2 months? See, our title itself will get confirmation only after 3 months or 4 months. How can we complete? Yes, It is possible with the help of machine learning techniques. So in this webinar, I will giving you some secret tips to complete the work soon and then spend most of the time for writing the paper. Okay, even the hardware prototype which you are going to develop, that work and also your paper work should go parallelly. Okay, then only within 6 months you can able to bring one IEEE transactions. And if you are not interested with the Web of Science or else impact factor based journals, the Scopus journals you can able to publish within 1 month one paper, 1 month one paper. Scopus articles. How it is possible? It is possible while you're adopting this machine learning based methods for any kind of typical problems. The first prerequisite is data. You have to collect the data. Here comes a question, sir, how to collect the data? When I ask any of my friends about the data, they are not giving me the data. How I can able to collect the data? There are 6 methods available to collect the data. 6 methods. We will see one by one. The first method is very simple method with the help of mathematical modeling. So why we are using the mathematical modeling? For an example, you are going to model a DC to DC converter like the mathematical model of 2x plus y plus 3z is equal to -1. You modeled your converter like this. And then you vary the parameter of x and y and z, you can able to get the various data. That is called mathematical modeling. That is the reason the people, those are studying the subject called process control or a chemical process control, what they will do, they will be studying mostly on control systems. Because the process control industry, what they deal is on chemical based industries. These chemical based industries are not approachable by the students. So what we have to do, we have to model the chemical industry in the mathematically. So that mathematically we are going to model that particular industry, and by varying the parameters, by varying the parameters, we can able to see the collection of data set. Mathematical modeling is a very, very important aspect for what every engineer should know. So I have done some mathematical modeling in the inverter side and the converter side, and also in the solar PV side. So this mathematical modeling will help you in order to achieve the data set. And the second method, sir, I don't know mathematical modeling. You tell about the other method. The other method is going to use a very great amount of time in simulation. So whatever your work you're going to interested to do with, you just simulate that particular thing by varying either the load side parameter or source side parameter, we can able to collect the data. And the third method is, sir, I don't have mathematical model. I don't have simulation. What is the other method? You can work with the hardware. Okay, so you can able to work with the hardware. By varying the parameters, you can collect the data. Sir, I don't want all these things. What is the next method? You can able to write a formula-based method. Formula means, for an example, many people for improving the power quality, they will be using the Fourier series analysis. The Fourier series analysis will tell you what is the corresponding output voltage V0 and what is the individual voltage of the solar PV. We can able to achieve the value of a corresponding alpha. So for the different output voltages and the different PV voltages, we can achieve the different set of switching angles with the help of formula. I mostly prefer the fourth method. Fourth method, that is to collect the data set by making use of the Fourier, because much of my works are inverter oriented. So for inverter oriented, I can directly use the Fourier series analysis or Fourier expression, that is V0 of omega t is equal to A0 divided by 2 plus summation n is equal to 1 to infinity an cos n omega t plus bn sin n omega. Using that formula, we can able to achieve the different set of data set. That's the one. What is the next method? Sir, I don't want all these things. You can able to get the data set, okay, with your base papers, but you have to cite it. Base papers, you have to cite the paper about the data set. And last method of collecting the data set is you can make use of the IEEE data port. In the IEEE data port, you can able to get the variety of data. So these are the different methods you can able to collect the data, which you are going to spend much of your time. And finally, you can able to get the data set in your hand. So once I already mentioned you that, please write one more Fourier series method. So that I will show you now for Fourier series. Okay, that's what I will explain. So I can able to show the Fourier series expression for you. Okay, this is an expression for Fourier series. For the work which I done for the multi-level inverter, so we can able to understand that V naught of omega t will be equal to A naught by 2 plus summation n is equal to 1 to infinity A n cos n omega t and plus Vn sin n omega t. Okay, so this is the V naught of omega t. So A naught by 2 will be a DC component, so I'm not using that one. So if I want to eliminate the number of harmonics, for an example, I want to eliminate the first order, fifth order harmonics, seventh order harmonics. So I'm going to make that, this is the 4 by pi n, that is your value. And this is the first PV voltage and cos n alpha 1. So where n refers to the number of order of harmonics. N is the number of order of harmonics. So I'm going to make the 157 up to infinity. So this equation I can able to continue up to infinity level, but I'm going to limit for my inverter rating. And then this is the first equation, and the second equation says that the second input and the n is the order of harmonics and then alpha 2. So in this expression, what we can able to do, what is your output voltage of your inverter. So you know 4 divided by pi, you can substitute. N is the how many number of order of harmonics you are going to eliminate. So I'm going to eliminate three orders of considering your number of harmonics, consider n. So and then you are going to substitute n is equal to 1 and n is equal to 1. You can able to make it as equation number 1. And then the second equation, you are going to substitute n is equal to 5. And the third equation, you are going to substitute n is equal to 7. So based upon that, you will get the typical equation like this. That is, for if I want to eliminate this equations like that, that is, I want to eliminate fifth order, okay, seventh order of harmonics, n is equal to 5, n is equal to 7, n is equal to 11, and n is equal to 13. So this is the base equation, and then I want to make first, second, third, and fourth. So I can able to get the linear algebraic equation like this, and this equations can be solved either manually, but if it takes much more time to solve it manually, so we can able to make use of a software called MathCAD. So MathCAD is a software which is helpful to solve the nonlinear algebraic equations. So what is your fundamental voltage, what is your DC voltage, and what is your input voltage of solar PV. So first is solar PV, second solar PV, third solar PV, fourth solar PV, fifth solar PV. So I'm using the 5 inverters and 5 input sources. So my block diagram will be something like, so 5 inverters, okay. 5 inverters will be there and 5 solar PV will be there. So this 5 solar PV will be powering my 5 different inverters. So what are the 5 PV voltages I'm going to give over here? And then I want the same thing for first, second, same thing. First one, first panel voltage, second panel voltage, third panel voltage, fourth panel, and fifth panel voltage. Fine. Next, I want to consider the order of harmonics. So here in this particular equation, I'm interested to eliminate fifth order, seventh order, 11th order, 13th order. So we can able to understand whenever you're going to use a 5 inverters, whenever you're going for 5 inverters, you can able to eliminate or reduce 4 harmonic orders. That is 5 minus 1, you will get 4. So this is the 4. This is your choice. Whether you are going to reduce the lower order harmonics or whether you're going to reduce the higher order harmonics. Normally, we focus only on the lower order harmonics because the higher order harmonics, once it achieve the steady state operation, it will get substantially reduced. So we focus on the lower order harmonics. So in this equation, my target is I want to find the value of alpha 1, alpha 2, alpha 3, alpha 4, alpha 5, because all other values I know. All other values are known. That is 5 panel voltage I known. Okay. And also fundamental voltage I known. And what is the input DC voltage I known. So everything I known. The only unknown is alpha 1 to alpha 5. So in the MathCAD software, what I will do, I will give the 5 panel voltages. The first panel voltage is 40, second is 41, third is 43, and fourth is 46, and fifth is 47. So in the MathCAD, I will enter this panel voltages. Based upon this Fourier equation, I can able to get the value of theta. So theta is the switching angles in radians per second. Okay, so I can able to obtain this value of theta. So whenever the panel voltages are coming like this, I can able to get the alpha or theta switching pulses will be like this. So my data set is ready. So as I already mentioned you that whenever we are working with this machine learning based system, you have to cook up the data set. So once your data set is ready, your work is 99%. The reason why I'm showing this Fourier series means because I got one question from the chat box that to write the Fourier series expression. So it does not mean that you have to use the same Fourier series. You can able to work as per your model. For an example, if you're working with a StatCam model, you're going to work with a shunt active filter. You can able to create your own equation because these kind of machine learning models are also called as model free learning. Model free learning means there is no particular model in which you have to follow. There is no model. So we can able to apply any kind of thing. Okay, so you can able to apply any kind of model. So for given set of inputs, I want to achieve the given set of outputs. As like the AND gate. What is AND gate? AND gate is having two inputs. 0, 0, 0, 1, 1, 0, 1, 1. What is the corresponding output? I want to get 0, 0, 0, 1. So for the given set of input, I want to make my system to learn this corresponding output. Similarly, you consider this is the input of my AND gate. When this input comes, I want to give the output for my inverter like this. Now looking back again to our this particular machine learning. So here we can able to give, we are seeing looking across to the example number 1. So the example number 1, I want to predict the house prices. So for the given set of X1, you can able to obtain the given set of X2 based upon the data. For an example, for feet of 500 square feet, you can able to purchase with the 100 into 1000 US dollars. And 750 square feet, you can able to obtain what's the price. And again for 750, for 800, you can able to achieve the price. For 900, so this is the data set, data points. So considering this particular data, we can able to we can able to obtain there. You can able to see the house which is available as a 750 square feet. We can able to see from this graph itself. You can able to see 750 square feet. You can able to achieve from some kind of prices that has been available on the y-axis. This is the normal supervised learning. What is supervised learning? For given set of X1, you know given set of X2. That is called supervised. For an example, for a given set of X1, you don't know the given set of X2 mean that is called unsupervised. So whatever the rate they are telling for 750, that will be the rate. We want everything to be in a supervised. And what approaches we are going to solve for the 750 square feet. For an example, if you're going to draw a straight line at the 750, we can able to see that it comes around 150,000 US dollars over here. Whenever you're going to draw a straight line, or whenever you're going to draw a polynomial structure like this, it may be around, let us say that I want to draw a connecting the polynomial, we can able to see it comes around as a 200 into 1000 US dollars. So we want to know which one I want to choose. See, as per when the price is less, we can able to understand by using a straight line, the price is less. But when you're choosing a second order polynomial, you can able to understand the price is increased. So you should understand whether which one to choose, whether a straight line or a curved line. But straight line only giving the less answer. So this we are going to make an approach. We are going to make doing a supervised learning. So in the algorithm, I'm going to give a given data set will be given, and I've also given the right answer also. Okay, so whether I want to go with a straight line like this, or whether I'm going to draw a second order polynomial. So there comes a confusion. So if I go for the straight line, I can be able to give the less price, but the seller may not willing to do that, because he may say that you have to follow only second order polynomial. You have to pay 200,000 US dollars. To avoid this ambiguity, we are going to make sure that, the idea, we are going to make the price that is to get a value of a training data. So to avoid this particular ambiguity, whether to go over straight line, whether to go over first order polynomial, second order polynomial, we are going to create a machine learning. So the algorithm you're going to write, so that algorithm will provide more right answers based upon the new training data, where we don't know the price already. Okay, we don't know the price already because we have created a model like this. For an example, in a Raipur, well, let us take that you are taking a Raipur. In the Raipur, let us say that some X, Y, Z Nagar or X, Y, Z plot is available. I want to buy. So for this X, Y, Z, what I'm going to do, I'm going to write a regression equation. That is, I'm going to write an equation. That equation may be a straight line like this, or the equation may be a like this. It may be, or the equation may be like this. Okay, so based upon the result 10, I can able to follow this one and this one and this one. So based upon the data set which I am having. So some data set may be increasing very linearly. Then it is called a linear regression. Okay, and some data set may be going with a logistically. This is called logistic regression. Okay, and some data will be going from starting from here, going here, coming here like this. This is called as a locally weighted regression. So regression problem also can be classified into different types. That depends upon your data set. Your data set only makes that, for example, I'm taking a Raipur, a place called XYZ. So in that place data set, I'm going to create the model. Now this model, I'm going to sell to the seller or a buyer. Now what will happen? Now I'm going to give you are going to give a new data set. Okay, we are going to go know the new data set. For that data set, I don't know what is the price. Okay, you're giving a new data set. I don't know the price. For an example, you're giving that you want to buy a 600 square feet. So with the help of my model, this 600 square feet will check whether it meets the line or not. So this line will show the optimal price for that particular XYZ location. So you are giving a 600 square feet. The 600 square feet, I want to see whether it matches over here or whether it matches over here means I can able to say that, it fits your regression model. So based upon that, you can able to predict the continuous valued output, where you can able to predict the price. Okay, so whether it is false on the model or whether it is falling away from the regression model or whether it is very near to the regression model, based upon that, you can predict the price. So there is no real discrete delineation will be available because we are not going. So as per this particular thing, I can have some people will say that you have to go to the straight line. Some people will say that you have to go to the first order polynomial or second order polynomial. But here in this method, to avoid this, we are going for the regression where for each and every place, I'm going to make a equation. You can ask a question, sir, how to create this straight line? So we are having a formula. We are having a straight line formula that y is equal to mx plus c. So we want to calculate with the help of your input data x1, that is a feet, and x2 is a price. So based upon the earlier data sets, based upon the training data set, we can able to substitute in this equation. And finally, you can able to arrive a straight line or else you can able to arrive some kind. That is because of the non-linear data. For linear data, you will get in this equation. It can fit in this equation. For an example, for a non-linear data, what it will happen? It can one data will be here, one data will be here, one data will be here. So you will not get a straight line. You will get either a logistic line or else a locally weighted line. So now the second example. So now I want to define a breast cancer because we know that the cancer can be classified as either malignant or a benign. Okay, so based upon the tumor size, I can able to classify. So here, how we can able to adapt to a power electronics problem, I can able to give based upon the value of my voltage, I can able to classify that either it is a higher over voltage or under voltage. So this is called as a classification problem. So I'm going to classify based upon the size. So earlier I said that a regression. So machine learning, because here it is my role to make you understand that, it is quite different from neural networks and fuzzy logic. In neural networks and fuzzy logic, we won't talk much about the regression, classification and all. But in the machine learning, we talk more about the regression problems. So here we get, next one will be the classification. And then we are going to even classify into two discrete classes, either a benign or malignant, or in malignant, what are the different types, and based upon that, we can plot the graph. So till now, we understood that the machine learning, the basic topologies are, first one is regression and second one is classification. So in the supervised learning, we can able to say that, this is a very, very important, that is, we are making use of attributes. What is called as attributes? Attribute means that is, we may call as a size or age or color or something different parameters. So even we talk about the attributes as high voltage, low voltage. So these attributes we normally talk about in our fault tolerance systems. When we work in the power electronics, we work on the attributes. Okay. So for the given fault, okay, for an example, for the given value of the voltage, what will be the fault, whether it's an open circuit fault or short circuit fault. So based upon the attribute, we can able to classify into class A and class B. So based upon the attribute, we can classify it as either a faulty section or a healthy section. Okay, so now here comes, while we are going to classify, now many peoples are working with one more algorithm. Okay, hopefully you have talked about an algorithm called support vector machines. Many people, it's not like our space vector modulation. You should not confuse, because in the power electronics, SVM means we talk about on space and vector and then modulation. We talk about on space vector modulation as a power electronics person. But in the machine learning, we talk about on support, and V stands for vector, and then it is called as machines. So this is a very important algorithm. Okay, as like a regression classification, this is very important algorithm. I will explain you in a very, very simple manner how to implement the support vector machines. For an example, many peoples are working with a support vector machine. Let us say that I'm going to take this as an open circuit fault and this is a short circuit fault. Okay, or else you take anything based upon a thing. Now, by looking at the data itself, we can able to classify like this. By looking at the data, because the data set is very small. So by looking at the data itself, we classify that this line, we normally call it as a hyperplane. So hyperplane is a one which classifies two data into two different pieces. Maybe one or two data will be available over here, and short circuit data will available over here. That may be possible, one or two. That speaks about our accuracy. That means the solution is not 100% accurate. So by looking at this, you are drawing a hyperplane. But you're having thousands of data or n number of data. How will you draw this hyperplane? How will you draw the hyperplane? For that, you can able to understand. So whenever based upon the classification between these two classes, let us say there's a class A or class B, or we normally talk this as a positive class or the negative class. So we take the nearby data over here. This is a very nearby data. And here we can able to understand these are the nearby data. We are not going to bother about all the data. So whichever the data are very near or closely with the class A and class B, these data set are called as a support vectors, or we normally call it as a simple vectors. So we are not going to use all the other data. So here we can able to see that some two data I'm taking. Here I'm going to take the three data. So using these two data and the three data, which will be called as vectors, I'm going to draw the hyperplane. So we can able to understand these vectors are supporting to draw the hyperplane. So it is called as a support vector machines. So while I'm teaching my machine learning class to my students, what I will do, I will be giving a chart like this. And I will be asking my students to draw the hyperplane. So what they will do, they will take two data from here, they will take three data from here. First, they will calculate the mean, and then they will calculate the covariance, and then they will calculate the distance between the mean and the covariance, and finally they will come to a conclusion that in which place I want to draw the hyperplane. So the hyperplane can be anywhere. So between these 2 points, anywhere. I want to find the optimal hyperplane. So for drawing the hyperplane, I'm going to use a three data from here and here. Okay. If you are very much interested with the support vector machines for your power electronics, you can contact me. I will explain you to solve the problem manually. You can ask a question, sir, why we want to solve the problem manually? Because we are having Python, we are having MATLAB to implement. But always, whenever you are studying any algorithm in machine learning, you have to solve the problem manually first. While solving manually only, you can able to understand what are the steps involved in each and every algorithms. While knowing the steps, you can able to write the program of your own. That is my objective. So the objective is you should not copy the program, because if you're going to GitHub, you can see so many programs are available. But many people, what they are doing, they will just change the data set, but the remaining programs are taken from the GitHub, and they will say that I have done this particular machine learning based, solved the problem in the power electronics with the help of this machine learning. That is, even you will not understand that one. But we have to always follow the straightforward approach. You take any one algorithm, solve it manually, and then check what are the steps involved, and then you can go step by step. By that lifetime thing, you can able to write any program for any different data set of your own, and even you can teach this support vector machine. And there are so many things: principal component analysis or linear discriminant analysis. These are some of the algorithms. Because earlier the people, they will be using some backpropagation algorithm. Backpropagation in the neural networks, they will be using some Adaline, Metaline, radial basis function network, learning vector quantization, so many algorithms. Now the people, they are turning to the principal common analysis, load discriminant. So these are also a classification problem. In the principal common analysis, the name itself will specify that it is called as a principal component, which is the main component to classify the two data. What is a linear discriminant analysis? I want to discriminate the data. So which is the linear thing? So all the algorithms are classification based algorithms. You can able to classify the data. If you're working with a transformer, you can able to classify the discharge rates. You can classify the values what you're going to obtain in a different manner. You can able to classify the parameter estimation or the survival estimation of a transformer. Everything can be done. So n number of opportunities or works are hidden in this particular machine learning. So now you can able to understand that we can able to see the supervised learning. We are going to draw the straight line, and we can able to make a more complex function to define the two groups, and we can able to define this particular thing. Now let us go for the unsupervised. Unsupervised means this is one of the second major problem. This is also called as unlabeled data. You will be given only X1, but you will not be given as a X2. Okay, you will not be given the X1, X2. So based upon the X1, you have to cluster. Cluster means it is called as a grouping. That is also called as a clustering algorithm. So in the machine learning algorithm today, you understood what is meant by the regression algorithm. You understood the classification algorithm. Now we are speaking about the clustering algorithm. So for example of the clustering algorithm means you are taking the Google News. So the Google News, it has been divided into clusters. Okay, if you're interested for the sports or politics or with the economics, or with the help of some entertainment. So based upon that, we can able to group the stories in the cohesive group. That is called clustering algorithm based upon the thing. And also the clustering algorithm can also be classified as genomics. So genomics means, let us take any kind of genetic structure of individuals. So everybody is having the 23 pairs of chromosome. So the genetic structure will be differ from person to person. So that is called as the unsupervised, because I don't know in which classification I belongs to, because my chromosome only, it defines my color, my height, my hair intensity, whether my hair is black or white or brown. Everything is dictated by my group of chromosomes. So it may differ from person to person. So we don't know that, but we know that, we are having a chromosome. So for the individual set of the values, what will be the expression for a gene can be done by the unsupervised learning. So let us say that we are going to discuss about the linear regression, as we already discussed about the size and the feet. This is also called a supervised learning regression. So whenever you start any machine learning problem, you need to get the training data set, or this called the data set. And there's a number of, M is called as a number of training examples. And we need the input features, that is called as your size, and output features, that is called as your target value. And X and Y is called a single input. And X of I and Y of J is called as your number of training samples. And I is the index of the training set. So we know that, we are having this supervised X1 and the X2 will be there. So what to do next once you get the training data? So you have to send to the training algorithm. So the algorithm will be output some hypothesis. What is, we normally in this machine learning, we come across the word called hypothesis. Hypothesis means it is also called as a research statement, or it is also called as a research question. Because in many of the proposals, they will be asking you about the hypothesis. Hypothesis means what problem you are going to solve. So here we are going to make a hypothesis that I want to predict the size of predict the price of the house, okay, for the new house. So I want to create an hypothesis. So this hypothesis can be created by h theta of x. So with a 0 initial condition, plus I'm going to make use of the gradient, which will be multiplied by the function of x. Okay, so where this y is called as my output and x is called as my input. And theta naught will be called as a 0 condition and theta 1 is called as a gradient. So here we can able to understand that is my data set will start from theta naught, and based upon my parameter and variations, my theta 1 may vary based upon my gradient size. This is also called as a univariate linear regression. So for every implementation, we want a cost function. This cost function is also called as the objective function. This cost function is also called as a fitness function. We want to create an equation. As I already mentioned you, based upon your input and output plus samples, either you create an equation as y is equal to mx plus c. So based upon your data set of x1 and x2, we can create an equation. Okay, based upon the parameters of x1, x2, we can able to calculate the b0 value and the b1 value, where we are having a specific formulas, and finally we can be able to arrive a fitness function. Now the fitness function may be a straight line. So we can based upon a training set, we can able to generate the parameters that is going to be a straight line. For as far as linear regression is concerned, we will be getting a straight line. So we can able to see that, that is our hypothesis. So the straight line will define your hypothesis. So the straight line will imitate, it's called imitator, imitate your research problem. So how it imitates, let us say that, I'm going to say this is an hypothesis. So we can able to understand, we are getting this h theta of x is called as your imitating your value. So for the given set of input, we will be getting the given set of output with the corresponding value of the initial condition theta naught and the gradient of theta 1. So the cost function is, what is the cost function is? So we are getting a model. So I prepared the model for the Raipur and the plane of XYZ plot, and that is hypothesis function. So this is also called as a square error cost function. So this cost function is a reasonable choice for most of the regression problems. So here we can able to see that, the problem set has been given. When a new set of data set arrives, I can able to see that, whether my data set is fitting to my hypothesis, or if the data set, it fits to my research problem, or it is away from my research problem, or it is very nearer to my research problem, or whether I can able to take the problem with the data set for my analysis, or some data set is moving very away. Those kind of things we can able to analyze. Okay, so now this is so I will explain you this regression with the help of one data set. Let us say that, I can able to ensure now, and I can able to go with my Google Colab. Okay, so where we can able to see that. So we normally do some kind of laboratory for the students, so we can able to see that this is one of the Colab things for making a linear regression. Okay, so where we can able to see that, that is, we are going to import this mathematical functions, that is NumPy, and there is a pandas as a PD. Okay, as a pandas, I'm taking it as a PD, and then I'm going to make some matplot library, and a NumPy, that is a Python number, I'm going to make it as a NP. So this is going to be the header files, and then I'm going to make some set of data set. Let us say that my data set I'm going to take from one of the location which has been given. So here it is a salary for each and everything. For business analyst 1, the salary, junior consultant 2, the salary has been given. So the data set, either you can take the data set from any other location, or you can able to cook up the data set. So once you cook up the data set, we can able to see that I'm going to make a scaling of x and y parameters. And then I'm going to make as a import linear regression, because in much of the program, so that is the biggest advantage of going Python. Even if you don't know Python, At the end of the session, I will be sending a simple book to Anamika ma'am, and she will be sharing that book to all the students. You please go through that particular book and you will write any program for your project, for a linear regression or anything. Not the linear regression is a starting step. The role of this webinar is only to make the students to understand that how simple learning the Python, how simple in creating the thing. So I'm going to make the sklearn library, the importing the linear regression. For an example, if you're going to use some other programming languages, what we will do, we have to write the linear regression equations and everything like that. And finally, I'm going to make a line for the regressions called the linear regression. And I want to fit my x input and y output. I want to fit whether my inputs data points are fitting towards my research problem. That's all. So you have completed this algorithm. For an example, if you take any power electronics problem, you take the data set. That's all. And the remaining things, if you want to work with a linear regression, all these contents remain the same. So now you want to make a plot. That plot you can make any of the colors. This is the setting of colors, and then you setting of the title or x-axis and y-axis, and then we can able to create the run button over here. Because the biggest advantage of this collaboratory is, you no need to install any MATLAB, or you don't want to install any kind of softwares that has been higher price. Okay, you have to go for the softwares, and you have to go for any kind of license renewal like that. It's a Google. Okay, so by that you can able to get the linear regression model. So you can able to understand that for the given problem, you're having the position level and the salary has been given x and y axis. For the given problem, the regression point, the blue color line, is a linear regression has been drawn. Now, if any new employee is coming, means, so they can able to give the new input data set, and they can able to see in which salary band the person belongs to. So based upon the present hypothesis, so we know that the so
अच्छा ये डायरेक्ट
So,
उसमें पढ़ा रहे क्या जाके?
Wait, I will check.
कब तक जाओगे घर?
Yes, sir,
okay.
now it
Mute
is.
your mic. You can mute your mic, Anamika madam.
Yes, I did.
Yeah.
So based upon if a new employee is coming, so based upon their cadre, based upon this model, because this model is created for your company. This model you created for your company because the data set was created for your company. So based upon the regression model, so you can able to see that, based upon the position level, the salary, how the variation of salary has been there. This is the very simple point of a regression problem. So like this, we have been making across a new kind of many programs. Let us say that we talk about on the first thing, So here we talk about on the another set of regression problem. So here we made across files, we made so there are so many things are available. This is called as a one more regression. This is not a straight line regression. We made across for the locally weighted regression. So once we understand this regression, once we understand this particular thing, it is very easy to get more approach to the machine learning based model. Now let us say that, in the machine learning algorithms, they are broadly classified into two types. That's what we are discussing. One is called supervised, another is called unsupervised. In supervised means you know the data, you know the target. Whereas unsupervised, you don't know the target. You can just group the data based upon input data. There is no target available. So supervised data can be classified into regression. That's what the regression, what we have discussed using the Python coding. And supervised can also be used in the classification problem. I want to classify the brain tumor like that. So for an example, the regression problem can be useful for the electricity load forecasting. Electricity load forecasting means, you take any power system model. In the power system model, for the given model, you create an equation, and that particular equation, you can create a regression problem. And based upon the load matrix and the load emitting, you can able to see whether that particular new load, it satisfies your model, or the new load is coming very nearer to your model or away to your model. And then algorithmic trading and the price prediction of houses. That's what we are discussing. And BMI index data based upon your age and height, what BMI to be there. That is the regression. For an example, for age number 15, I have created a model of a BMI. For age number 15, I have created the BMI. Now the person who is coming at the age number 15, he is giving his BMI data. For an example, his BMI is over here. So as per the normal age of 15, the BMI should be in this particular regression line. But we can able to see that this particular person is having the BMI just away from my regression point. So with a graphical illustration, so machine learning is completely on graphical illustration, or we call it as a graphical visualization. We want to visualize it. That is how your data set is oriented towards one point, or whether the data set is moving away from the point. So that is called regression, which is also called as a curve fitting. So now you can able to see how the difference of this, because here in this machine learning algorithm, we have not talked about on the weight calculation, what we talk about on ANN. No, we are not talking about the weight calculation. We are not talking about the bias, and we are not talking about anything of the error back propagation and all. Those things are neural networks. Okay, machine learning is completely on two things. One is on data science, and another one is called the visualization of your output. Visualization of the output. And similarly for the classification, we can able to classify the spam filtering. For an example, you can able to spam. For an example, you're getting so many emails. So many emails you are getting. So you are some 50 or 60 users. 50 or 60 users, they are classifying their, they are saying that this email is a spam. So obviously what will happen? Whenever you get a new email, so that will be marked as a spam. Okay, and credit scoring, medical image processing, speech recognition, language detection, that is comes under the classification. When we go across to the clustering is grouping. We can able to group the market segmentation, face recognition, positioning of a cell phone device, social network analysis, and organized computing clusters. This is the difference between the three different machine learning basic algorithms. One is called as a classification. You can able to classify this, let us say this is a red or green. Okay, so when a new person comes, you can able to get ambiguity that whether you want to classify to here or here. So what you have to do, you have to check the parameters that under which parameter it closely associated, whether the new blue is closely associated with here or here. That's called classification. Clustering means it's called group. For an example, you take a NIT Raipur. I want to cluster the students, means the students are always let us take, they are on the blue color. All are same. Students are all are same. So I'm going to classify, cluster means group the students as electrical, and I'm grouping as electronics or mechanical. So grouping, that is called clustering. Okay, based upon the parameter, I'm going to make a clustering. Regression means, these are the two different regression. So based upon my hypothesis, I'm drawing this straight line, and then whichever I'm going to check which are the data points are just satisfies my hypothesis and which are away from my hypothesis, like that. So the regression can be a straight line, or else it may be a sigmoidal. So these are the visualization we can able to show. Let us take that if you are going to solve any power electronics problem, you can able to classify the voltage and current. You can able to classify the MPPT duty cycles. You can able to make a regression for the problem. So we can able to visualize it one. Unlike doing the same thing in a neural networks or fuzzy logic, we can able to make some visualization of the machine learning algorithms. So what are the steps involved in the machine learning? So first one, as I said, you have to collect the data. So normally how we will collect the data? You will collect the data from the sensors, temperature sensor, and then from the normal sensors, you collect the data. So once the data is collected, you should not use this data. You have to go for the data pre-processing that we normally call as a cleaning of data. Once the cleaning of data is completed, you have to extract the parameters from the data. Once the data has been extracted, then you can go into apply for the machine learning predictions. If you're taking the environmental data after the pre-processing and the future extractions, you can able to apply for the machine learning. So in the machine learning, we can able to see that one is called as a regressive model. That's what we have discussed, the regressive model. That is a very basic and a fundamental model. And second one is a support vector machine. As I say that, what is support vector machine? So whenever we are having the two different clustering, we are going to decide a hyperplane. And next is called as a random forest. Random forest means, randomly you're going to select the thing. And then for learning the machine learning, this is the very important thing. Two things we have to study. One is called the probability and another is called statistics. So these are the two basic mathematics we want to remember whenever you're going for the machine learning. Under machine learning umbrella, one such behavior only is called neural networks. One such concept. But many people have done with the neural networks. But I recommend the people to be work with more on support vector machine, random forest, principal component analysis, PCA, LDA, Bayes, naive basis, softmax algorithms. A number of algorithms are available, and based upon that, we can able to make a forecasting for the future, or else we can able to make a appropriate decision making. So when we talk about on classification problem, we can able to classify the discrete values. The normal classification is we are going to classify as a male or female, true or false, whether the email is spam or not a spam. This is the difference between the classification and the regression problem. Classification means I'm going to classify the two things. Okay, so let us say that we talk about an electrical and mechanical classify. Regression means, for the given problem, how many data sets are nearby to my hypothesis and how many stays away from my hypothesis. And for the new data set, and what is the appropriate prediction value. That's called regression. And the classification is we are going to classify the things, and then the example of classification is we are going to classify whether the email is normal or email is spam. So these are the different types of classification algorithm. That is called logistic regression, nearest neighbors, support vector machine, kernel support vector machine, naive Bayes algorithm, decision tree classification, random trees classification. So this is the different thing. So what I suggest to the student is you take any one research problem. Take any one research problem. Let that problem may be classification. You apply all these algorithms and collect the results and compare the results. And then you say which algorithm is showing a better accuracy for your research problem. That's what I recommend, because you are working with any one problem and any one thing and submitting the thesis, you can able to get a good publication, only one publication. But when you're going across all the different networks, n number of algorithms, and you can able to get a variety of graph visualization, and you can able to make a nice papers. You can ask a question, sir, while I'm implementing all these algorithms, we can able to see it consumes more number of time. Yes, it will never consume more number of time. As I already shown you in the Python, you can able to see there are so many libraries are available for each and everything. No need to write the equations, no need to write the formulas, just to write support vector machines. So what are the formulas associated with a particular keyword, it can able to resemble, and then you can able to complete the one algorithm within 30 minutes. Okay, that's all. And the completion of the algorithm will complete within 30 minutes. But as I already mentioned you, before processing that, your data set should be in your hand. That covers only the 99% of the work. And there are other set of learning is also called as an instance-based learning. So which will estimate the entire thing rather than going for each and everything. It is going to make a local approximations of the target function. So these are the different types of instance-based learning, like self-organizing map, nearest neighbor, learning weighted quantization, locally weighted learning, and core-based reasoning. So I've done one simple case study for to show you. So these are the different types of unsupervised learning methods, and these are the different set of supervised learning methods. I will show you one simple coding in MATLAB. So till now I explained in the Python. Now we can go for the MATLAB. Let us say that I'm going to explain with a simple coding in a MATLAB. So let us say that, it's a sample coding. Let us say this is the normal thing in a MATLAB. I'm giving some set of inputs, corresponding value of output. Okay, so this is my data set. Okay, so for corresponding value of V1 to V7, and what is the value of alpha 1 to alpha 5? So that is given in the matrix declaration. And now these three lines in the MATLAB will help you to create one algorithm. That is, the first line we talk about net. Net means network. You're going to start a new FF. There is a new feed forward network. I want to make a min max. That's called a scaling command. I want to find what is the minimum value, maximum value. And this shows the number of neurons in the hidden. This shows the number of neurons in the output. And this is called as my activation functions between my input to the hidden and from hidden to the output. So two activation functions, and sigmoid activation function. This is a normal network creation. Now, I want to make a training the model. So I'm going to make a train the model with the LM. LM stands for Levenberg-Marquardt algorithm. Levenberg-Marquardt algorithm. So I want to train with my network, with my input and my output. So if you are studying this Levenberg-Marquardt algorithm in the textbook, so that algorithm will go across so many manual solving like this. That is, it will consisting of so many equations and then weight calculations and everything. So all these things can be made with a simple keyword of LM. So it will train your network, and finally you are going to generate a box, a machine learning or neural network box. So whenever giving the input, this model will create the corresponding output. That's all. So based upon that, you can ask a question, sir, you are given the LM. Similarly, you can able to see these are the various training commands given in the MATLAB. Okay, so I have used this algorithm. For an example, for my same research problem, you can use this algorithm and you can write your paper that estimation of power quality in power electronics using gradient descent with adaptive learning rate back propagation. That's all. But the thing is that you're using only GDA instead of this LM. You are completing one algorithm. Either one Scopus paper is ready or one Web of Science paper is ready. You will not believe me. I have used only this 5 lines of coding in which the outcome of this particular codings, it resulted in 2 IEEE transactions. Okay, so 2 IEEE transaction paper has been arrived by just making the sample coding of 5 lines. Even I can share my paper. You can able to see the same logic only. It will be resembled over here. One paper is talks about on the power quality and one paper talks about on the fault tolerant systems. Okay, I have written only these 5 lines of coding. Earlier, when I was doing my undergrad and the postgrad, I used to write the coding for 50 or 60 lines. And later then, due to the advancement of the versions of MATLAB, the coding line was very much reduced. Even you can, instead of LM, you can able to use only the C and you can write a paper on cyclical order incremental update algorithm. Okay, so the options are unlimited as far as power electronic researchers are concerned. N number of each and every day, instead of LM, you put K, then your work will be coconut weight learning function. You take the output, compare with the LM, and then you can write a paper. That's all. So based upon this different value of functions, okay, so this is the thing what I was interested to show with. We are having this 5 solar panel connected to the inverter, connected to the load, and then based upon the voltage, and we are giving to the neural network, and you will give you the alpha value. That alpha is given to the triggered circuit and given to the H bridge inverter. This is what I already given explanation about the Fourier series, and now we are getting the data set. And this is the way, that is the trained neural network for the pulse generation. So we are giving the corresponding input. That is a 5 input. It produces the 5 outputs. That 5 outputs is converted into the pulse generation with help of this particular normal PWM technique. That is, now whenever we want to generate a PWM, because many people are thinking that this kind of intelligent technique will generate the pulse. No, the answer is no. This particular thing will generate a signal. That signal is also called as control signal, or it is also called as a modulating signal, or it is also called as a pulsed signal. That signal has to be compared with your carrier waveform. Okay, because this carrier waveform only will determine the switching frequency of your system. So this carrier will be compared with the output of my inverter, and all the things will be compared, and finally we're getting the pulses required for the inverter switches. And based upon that, we can able to obtain the 11 level waveform, and then we can able to obtain this conventional PWM. We can able to see the harmonics. Okay, and let us say that with help of the neural networks, we can able to suppress the harmonic orders. And let us say about that we also work for the 15 level inverter, corresponding input voltage and switching angles. It's a real-time implementation, and we have made this architecture with what I mentioned earlier, and the 11 level results. And then we achieved for the 15 level, we can able to see the lower order harmonics are highly eliminated or all reduced, and we got the THD of 5.69% with the corresponding values. And this also made as an experimental setup for the 7 inverters. And also this power quality analysis made with the help of my logic analyzer, and the power quality analysis we made with help of my Yokogawa make power quality analyzer, and then switching sequence have been made. And then finally we achieved the output, and it has been compared with all the authors, and we found that this has been giving a less results when compared to the other techniques. Okay, now actually I thought of completing by 6:30. I mentioned. So now it is open questions for the audience.
Thank you, Dr. Albert.
Thank you,
for
sir.
giving such a nice lecture on machine learning and power electronics. Since there are no questions in chat box, actually one query is there. Dr.
Yes, sir.
Mathur is asking, please write the Fourier series method once more.
Sir, he
Once
has
more.
already given the answer, sir. Thanks,
Okay,
sir,
so
for
he,
that.
so,
Yeah.
okay, so he has given the answer. Since there are no questions in chat box, I request the audience to ask question directly if they have any. Otherwise, you will go to vote of thanks. Yeah, you drop your mail. I will share the video link. You just drop your mail to atripathi@IEEE.org. My mail ID is this.
So these are the students also so I will share with them once I get the link.
You drop your mail. I will just give you the video link. Okay. So very much thank you very much, sir, for giving such a nice and interactive lecture. I request Dr. Shravani Mathur to present a vote of thanks.
Yes. Good evening, everyone present here. I, Shravani Mathur, Secretary, IEEE PELS Chapter of Madhya Pradesh, take the privilege to propose the vote of thanks for today's session. First of all, I would like to thank our today's eminent speaker, Dr. S. Albert Alexander, Associate Professor, Vellore Institute of Technology, Vellore, for such an informative and knowledgeable session. And then I would like to thanks to Dr. M.K. Badapanda, Chair, IEEE PELS Chapter of MP Section, for his continuous support and guidance. I would also like to thank Dr. Anamika Yadav ma'am for convincing Dr. Albert for this nice session. And I would like to thanks to Mr. Akhilesh Tripathi also for taking care of the technical part of this webinar. Last but not the least, I would thanks each and every person who attended this session from the bottom of my heart. So thank you, sir. Thanks once again to everyone. Thank you.
Thank you.
Thank you, Dr. Albert. And it's nice meeting you from, you have shifted to Vellore Pencil. When did you join Vellore?
Ma'am, I joined here by November. From November, I'm here in Vellore.
Okay, sir.
Okay. So soon I will invite you to Vellore physically. Very soon.
Yes, sir.
Okay.
Thank you, sir.
Okay.
It was nice meeting you. I recall the 2015-16 when we met
15,
there.
yes.
Yes.
Yes, ma'am. Yes.
During the
Thank you so much, ma'am. Thank you. Nice meeting you, ma'am. Thank you. Convey
Thank you
my
very
regards
much
to all
for
at home.
accepting
Thank you.
this invitation.
Can we have one photo with all of us? Can
Yes,
we
sir.
open the camera?
Yes, please, everyone, open your video, please.
All are requested to come in video mode so that we can take a few photographs. Okay. Okay. Thank you very much, sir.
Thank you, sir. Thank you so much. Thank you.
Okay.
Thank you.
Okay.
Thank you, sir.